This is the most anticipated stellar death of our time. When the giant star Betelgeuse turns into a supernova explosion, it will shine in the sky as bright as a full moon, and it can even be seen in daylight. However, unfortunately, we do not know exactly when this brutal demise will occur. After the Star Colossus was nearly declared dead, following some mysterious fluctuations in brightness, it was expected to recover. This has happened until now, as Betelgeuse is once again attracting attention with mysterious flashes of light, and new research has concluded that the shoulder star of Orion may explode much sooner than expected. In 2019 and 2020, the excitement surrounding Betelgeuse was boundless. The giant star indeed made headlines, sharply losing brightness, which many experts perceived as a harbinger of an impending supernova. Undoubtedly, the explosion of this gigantic celestial body will be a stunning spectacle. After all, the red supergiant, located just 650 light-years away, is 800 times larger in diameter than the Sun, and already shines 10,000 times brighter than our source of heat and life, invisible light. As a result, Betelgeuse is one of the brightest stars in the night sky. This is why the events that began in October 2019 seem even more puzzling. The star's usual luminosity is estimated at 0.3 to 0.4 magnitudes. In general terms, a magnitude unit, abbreviated as mag, denotes the apparent brightness of a star without taking into account the distance to the celestial body. The smaller the magnitude of a star, the brighter it appears to us in the sky. When Betelgeuse dimmed, researchers recorded a drop in brightness to 1.289 mag. At the same time, the temperature of the stellar giant fell by 100 degrees Celsius. Moreover, the drop in brightness was so significant that it could be noticed even with the naked eye, resulting in Betelgeuse dropping to 21st place on the night star chart. But how is it that astronomers associate such a spectacle with an impending supernova? On one hand, the so-called shoulder star of Orion has reached the final stage of development as a red supergiant, which will inevitably end with a powerful explosion. On the other hand, this may indicate strong expansion combined with decreasing brightness. But here arises the difficulty. The astronomical truth includes the fact that there have simply been no night observations of supernovae before their explosion. Due to this, we also do not know whether the dimming occurs several years before the supernova or just a few hours before it. However, we know that Betelgeuse should not disappear from the cosmic scene at this time, because we would inevitably have noticed it. According to experts, Betelgeuse will shine as brightly as the full moon for several weeks. The dying giant will be so bright that it will be practically impossible to see other stars in its vicinity. And since this will be the brightest supernova in the history of observations and the closest to Earth, it can even be seen in daylight. The largest drop in brightness over the past 2 years raises new questions. But if the dimming 5 years ago was not related to the last explosion, what caused it? Dust. Subsequent observations using the Hubble Space Telescope showed that a massive dust cloud formed as a result of a huge plasma eruption, which then dimmed the star by almost 2/3. And although Betelgeuse, being an old star, regularly ejects a large amount of stellar material, this event was entirely different. The combination of strong convection and expansion likely caused the plasma ejection to be 2 to 3 times stronger than usual and resulted in a mass loss 30 million times greater than that of the Sun. Soon after, Betelgeuse should have returned to its original brightness, and yet in the subsequent period, it still had 1 or 2 brightness mysteries in store for us. Thus, in 2023, events took a turn, and since then, the star has been shining significantly brighter than average. But following the motto, "Where there is light, there is also shadow," a few months ago, the celestial body experienced another sharp drop in brightness. And although the brightness has not changed as radically as in 2019-2020, researchers have still recorded the lowest luminosity in the last 2 years. In this regard, the question arises again: could this development be related to an impending supernova? And this time the answer is, we do not know. No expert can say with absolute certainty whether a giant star will explode tomorrow or in a million years. As a result, it is theoretically possible that Betelgeuse has long since left its blazing home, and the light from the last star just has not reached us yet. And here it is. A study conducted in 2023 concluded that Betelgeuse may explode much sooner than previously thought. In anticipation of this research, a research group from Tohoku University in Sendai studied the pulsation of the star and found a number of astonishing circumstances indicating that Betelgeuse is much older than previously believed. The pulsation of the outer layers of the shoulder star of Orion leads to relatively regular variations in brightness, the most noticeable of which last 2200 and 420 days, respectively. Until now, astronomers have interpreted the shorter interval as the star's heartbeat, suggesting that we are dealing with a younger celestial body. But what if the period of 2200 days truly represents a real stellar pulse? First of all, this means that Betelgeuse is even larger than commonly believed. To express this in numbers, an 800-fold solar diameter would become a diameter exceeding 1,200 times that of our mother star. This fact also indicates that Betelgeuse is at a later stage of its life cycle and that its supernova is inevitably approaching. Will Betelgeuse explode soon? The reason stars turn the night sky into an endless sea of shining points is explained by the spectacles occurring in their depths. Stars shine primarily because hydrogen is converted into helium in their cores, and as soon as the hydrogen reserves in the core are depleted, helium is used to create carbon, which with age burns up to form other heavier elements. The authors of the Japanese study used computer modeling to show how bright celestial bodies evolve from birth to the final pages of their lives, and at what stage they begin to pulsate, discovering an astonishing fact. Actually, all recorded pulsations of Betelgeuse can be attributed to a much later stage than previously thought, the stage of carbon burning. The study states that several decades after the carbon in the core is exhausted, a core collapse is expected, which will lead to a supernova explosion. Unfortunately, it has not been possible to determine the estimated date of the star's demise more accurately. Researchers only suggest that the time until carbon depletion may be less than a few hundred years, compared to other predictions which state that a supernova will not occur for another 100,000 years. This is significantly sooner. Still, it is worth noting that the research results from Japan are by no means free from criticism. For instance, astrophysicist Morgan McLeod criticizes that the information does not align with other studies of the star. More precisely, if we consider the 2200-day cycle as the main pulse, then Betelgeuse will become too large, so there remain at least several question marks over the new results. However, it is not ruled out that Betelgeuse is accompanied by not just question marks, but something entirely different. According to new analyses, it has a partner star, the existence of which has eluded humanity for thousands of years. In this case, the astronomical interest has focused on the longer 2200-day oscillations. A recent reevaluation conducted by a team from the Flatiron Institute in New York has revealed several surprising anomalies. For instance, the fact that the 2200-day cycle in the star's brightness curve follows a different rhythm than the barely noticeable 400-day pulsations. However, scientists have been unable to identify any accompanying phenomena that could be linked to causes such as rotation sequences, magnetic field effects, or convective currents. Thus, in the end, only one explanation remained that could plausibly account for the long-period oscillations: the existence of a smaller companion star. On the contrary, the long-period brightness oscillations would reflect the orbits of the partner. As soon as it disappears behind Betelgeuse from our perspective, the cycle is at the point of minimum brightness. However, if the companion is close to Betelgeuse, the luminosities of the two stars combine, and the brightness reaches its maximum. At the same time, the companion star may act as a natural dust mover, influencing the distribution of dust clouds, and thus playing an additional role in the change of Betelgeuse's brightness. But even if we assume that this is indeed the case, how is it that we have not noticed the companion star for so long? Most likely, this is related to its small mass. According to experts' calculations, it weighs only 1/7 of the solar mass, meaning it is almost 12 times lighter than its much larger sibling. Additionally, it is believed that the companion star orbits Betelgeuse at a fairly small distance, equivalent to just 2.43 radii of Betelgeuse. As a result, the companion literally eclipses Betelgeuse, and its pulsations, oscillations, and brightness further complicate the identification of the companion star. However, fortunately, complicated does not mean impossible, and now researchers hope to use large telescopes to find new evidence of the companion's existence and possibly even determine what kind of star it is.